Tonight's movie introduces the concept of binary names and symbols. You've seen a bunch of this back in grade 9 and more of it in grade 10, so I'm hoping I can go through most of this fairly quickly. So look over the slide, decide how much of the detail you need to write down. So when we're writing ionic names from the symbols, you write the name of the metal, you write the name of the nonmetal with the ending IDE. So if I'm looking at LIF, we're looking at lithium fluoride. I'm looking at Al2S3. I'm looking at aluminum sulfide. If I'm looking at MgO, I'm looking at magnesium oxide. So unlike the covalently bonded substances, I'm not looking at subscripts, I'm not using any prefixes, I'm just writing the name of the metal, the name of the nonmetal with the ending IDE. That's it. Going on now. When we're going to write the symbols, you write the charge for each element above its name, you then write the symbol, then you apply the crossover. Those charges come from either the column number for the metal or the non-metal column number and then subtract 8 to get the negative charge. So calcium bromide. Calcium is in group 2 on the periodic table, so it's going to have a charge of +2. Bromine is in group 7. 7 subtract 8 is -1. Write the symbols. Calcium is Ca, bromide will be Br, and then when we cross over, we ignore the signs, and that means 1 calcium and 2 bromine, CaBr2. Magnesium phosphide. Magnesium, like calcium, is in group 2, so it's +2. Phosphorus is in group 5. 5 minus 8 is -3. Magnesium is Mg. Phosphorus is P. Again, we cross over, so we get Mg3. And we get P2. Aluminum phosphide. Aluminum is in group 3, so it's +3. Phosphorus, like before, is -3. Al-P. Cross over, but they're both 3's. And this is where that simplify of able comes in step 3. Because I can divide 3 on both sides by 3 to get 1, so it's just ALP, no subscripts, no 1's, it's just simplified. If you get a 4:2 ratio, it simplifies to 2 and 1, simplify when possible. Moving on now. Multivalent cations. Now, some elements are capable of having different charges. And the possible charges are going to be given to you when I give you something called the ion sheet, which is going to look like this. And we're focused today on the top part of it. So you see a periodic table, and some of them have 1 charge, some have 2 charges. If there's only 1 charge given for the metal, it is not multivalent. It's a normal one like we've been dealing with for a couple of years now, and you just write them as normal. No brackets, no Roman numerals. However, when giving the name, the charge is written in brackets as Roman numerals if it is multivalent. So, copper was one of the elements on the page that had 2 different charges. Copper in brackets and then 2 capital I's means it's a copper with a +2 charge. All the rules for writing symbols still applies to get their names. So if I look at palladium 4 sulfide and I want the symbol, palladium has a charge of +4. I don't need to look at the periodic table because the Roman numeral gave me the charges +4. Sulfur is in group 6. 6 minus 8 is -2. Palladium is Pd. Sulfur is S. We're going to do the crossover rule. And that means I want 2 for palladium and 4 for sulfur, but I can simplify the ratio. So palladium is going to be 1 and sulfur is going to be 2. The simplified ratio would have put a 1 here. I'm putting it in red just so you know that you're not supposed to put it there. So don't put the 1 there. I'm just telling you that that's what the ratio simplifies to, but we never write the 1s. So let's not put the 1 there. So that aspect is really easy because the name gave the charge. We're now going to go the other way. When going from symbol to name, you have to figure out the charge on the metal ion. You have to work out the charge because you have to write it in its name. So here we have CuI. Copper is one of the metals that has 2 different charges in its name, or on the ion sheet. What I do is I start with the iodine. It's got a -1, and that's where the 1 came from. So with the 1 here, that had to come from the +1. So this means this is copper 1 iodide. Fe2O3. Now that I've got some subscripts, oxygen is in group 6, which means it has a charge of -2. -2 times 3, if I do the multiplication of that, gives me -6. And since it's a neutral compound, it has to add to 0. That means that all the positive ions have to add to +6, because +6 minus 6 equals 0. And now I'm going to divide that +6 divided by 2. +6 divided by 2, because there's 2 ions there, gives me +3. So that means this is iron 3 oxide. Let's try another one. COF2. Again, cobalt is another multivalent cation. The fluorine has a -1 charge. And whenever this has a -1 charge and there's a 1 there, we know that we can just use this to get the charge of the cobalt. So we've got cobalt 2 fluoride. NiP. Phosphorus has a charge of -3, and because there's only 1 of each, nitrogen has to be +3 in order for them to cancel. So that means that, nickel. So nickel 3 phosphide. Last one, CaCl2. Calcium, when you look on the ion sheet, has only 1 charge listed in it. It's +2. And that means it's not multivalent. So it's calcium chloride. So don't get in the habit of saying, I'm just going to write a Roman numeral for all of them. You have to look on that ion page, see which ones have more than 1 possible charge, and when it has more than 1 possible charge, you are going to need to give the Roman numeral. And that's tonight's movie. Thanks for watching.